Hey, good morning, afternoon, or evening, calculus people. Day 4 of our max min unit. And we're going to be looking at distance problem examples today. So I've got 2 of them that I'm going to do with you today. One's going to be minimizing cost. That's this first one here. And the second one that I have over here is minimizing time. Okay, so let's start off with this first one here. And this is, I'll give you a minute to get it down. And we're going to basically work it out step by step here. Okay, so let's read it first. Okay, a cable company, television company, is laying cable in an area with underground utilities. 2 subdivisions are located on opposite sides of a creek that's 100 meters wide. I said river here, but it's 100 meters wide, so this is my river here. And here it's 100 meters wide. Okay, and then it says the company has to connect point B with point Q, where cable where Q is on the north bank, that's up here, 1,200 meters east of P. So this is 1,200 from here to all the way over here on the south bank. So I wrote it a little bit differently. I put an X and a 1,200 minus X, but total this is 1,200 meters. It costs 40 meters to lay cable underground. That's this land part here, and 80 meters or $80 a meter to lay it underwater, which is this part here. What is the least expensive way to lay the cable? So I'm going to say let X be the distance at which the cable goes into the river. So that's what X is. Let me get my marker out here so that we can solve this. Okay, so X equals the point where the cable crosses the river. And then we're going to get that cost and minimize it. Okay, so this is X and this is 1,200 minus X then. So it's the distance from point Q towards the west. Okay. Now we have to get this cost here and we have to get this cost here. So we have to figure out what the hypotenuse is. So this is 100 meters and this is X. So we know X squared plus 100 squared is equal to R squared, or the hypotenuse squared. So we could say that this would actually be 100 squared plus X squared. But that's R squared. We don't want R squared, we want R, so we have to take the square root of it. So that's the distance crossing the river. So there's the distance crossing the river, there's the distance underground, and then this is just the distance that we need to get into the water. So the cost then is what we're trying to minimize. So we have to write a cost equation. So our cost equation, let me just get my timer out here. There we go. So I know what time it is. So we're going to do a cost equation. Okay, so the cost of going underground is, where is it here? It costs $40 per meter to lay cable underground. So that's going to equal $40 times the distance underground, which is 1,200 meters minus whatever that X is, plus the cost it's going to take for us to lay cable underwater is $80 a meter times this here, 100 squared plus X squared. And we'll go, instead of putting the root, we'll do it in power form to the power of 1/2 so that we can take derivatives. Okay, 1/2 is the same as square root. Okay, so that is our cost equation. Now we want to minimize this. So we're going to have to take the derivative and set this to 0. Take the derivative and set it and solve for x to find out what the distance is where we're going to start crossing the river. And then we can actually get our cost and figure it out. So let's move this down so we get a little more space here. Okay, so the first thing I can do is I can actually expand this part out here to help with our derivative. So 1,200 times 40 is 48,000, I believe. And subtract a 40x. And this we can't really expand out because we have a square root thing. We have to do the derivative of that. So we're just going to leave that as, we're going to get the 100 squared out. We're going to leave it as 80. And then we're going to write this as 100 squared, which would be, if we square 100, we get our 10,000. Plus x squared to the 1/2. Okay, so that's our cost equation. So we're going to take the derivative and set it to 0 of the cost. So C prime, which is going to be set to 0 to get our critical points or whatever. Okay, so 4,800 doesn't matter. There's no x there, so that's no derivative. So this would be negative 40. Okay. And then this would be, okay, this is where you have to use the chain rule idea when you're doing this. So it would be plus 1/2 times 80 times this whole thing, 10,000 plus x squared to the power of negative 1/2. Then we have to chain it, so we have to take the derivative inside, times 2x. Okay, so we can do some reducing here of our work. This is going to be 0 because we're setting it to 0. Negative 40. This would be 40 here times 2x out there. 40 here times 2x, that'd be 80x. So this would be plus 80x times this whole thing, 10,000 plus x squared to the negative 1/2. Okay, so that's our derivative. Now we have to try and solve for x. Well, how do we do this? Well, first thing that we're going to do is we're going to rewrite the equation back into fraction form and move the 40 over here. So if we move the 40 over and then we write the 80x on the top and we put this on the bottom, now that is everything under the root sign on the bottom. Okay, so there is what we have for an equation. You could also write this as just for the power of 1/2 if you like. Okay, so how do we solve this equation when we're doing this type of work? Well, basically, we can do a cross multiplication solve here. So we're going to get 40 times the root of 10,000 plus x squared equaling, and this would be like 40 over 1, 80x. Okay, so now we have to solve for the x somehow. How do we do this? Well, let's take the 40 and divide it out on both sides. So we have the square root of 10,000 plus x squared equals 2x. Okay, once we've got to that point, we're like, okay, how do I get this now? Now, we square both sides to get rid of that root sign. Okay, we square this side. So we're squaring both sides. So that eliminates that. So that gives us 10,000 plus x squared is equal to, what's 2x times 2x? That's 4x squared. All right. So collect the x squareds to one side. Subtract x squared, subtract x squared. So 10,000 equals 3x squared. 4x squared minus 1x squared. Okay, divide both sides by 3. So 10,000 divided by 3. 30,333 and a third. And square root both sides. Okay, so we're going to square root that. And I get 57.7 meters. So that means that we have to go 1,200 minus 57.7. So we have to go 1,142.3 meters down the river, and then cross the river. Or if you like, 57. This is 57.7, and this is 1,142.3 meters. So the question asks, what is the least expensive way to do it? So we will say that, you can say that cross the river at 1,142.3 meters down from point Q. Or you can say cross the river 57.7 meters west of point west of this point here. We can label that, say we'll call that T, labeling it west of T. So there's a couple different ways. Now, if I ask you the question, what is the cost? You could figure it out. So the total cost would equal, I don't know if I asked that, but if I did, so we cross the river at that. So we could go 1,142.3 times that cost, which was $40 per meter, plus 57. Oh, can't do 57.7. We have to do the whole 100 square root. We have to do this distance here, right? Because we're doing the cost here. So that's going to be whatever that is. We'll figure it out here. So let's do, for this cost, we have to do 100 squared minus 57.7 squared. What do we get? Okay, so and that's 6,000. Okay, and we'll square root that to get our distance across the river, which is 81.7 meters. So this would be plus the cost going across was under the water was 81.7 meters times $80. So the total cost would be 1142.3 times 40 plus 81.7 times 80. So our total cost is, our minimum cost was $52,228 if I asked that. But I think I asked how far down you need to go. That's the answer to the question. If I asked what would the minimum cost be, that's what it would be. That's our first example. Okay, that uses minimizing cost. Okay, and now we're going to do one, and that we're only doing two today, and then I'm not going to give you any practice today. I'll save it for a work period tomorrow on day 5. I've got 6 problems that you can work out, and I have to work the solutions out yet, but I will put those up as well. Okay, so let's go ahead and for this example here, where this was minimizing cost, I didn't title it. Okay, the next example is minimizing time. Okay, so it says an outdoorsman is at a point on a river. So he's here, and he's on the bottom side on the river here. He wants to get to his cabin located 5 kilometers north and 10 kilometers west of where he is. So I just drew it like this. This is a total of 10 kilometers. And here's the distance. I always put the X inside the triangle because it makes it for easier Pythagorean theorem. Okay. Rather than out here. And then this would be, you could do it either way, but I think it makes it easier if you put the X inside the triangle that you're going to use. So this is the river here that he's going to go, and then he's going to walk across here. He has a speed on the river of 8 kilometers an hour here, and then a walking speed of 3 kilometers an hour on this rocky land. So he wants to minimize his time to get to his cabin. So in terms of time, we know that time is equal to, if we're talking about speed and distance, time is equal to distance divided by speed. So that's what we're going to use to solve this one. We're going to minimize this time, but we first have to calculate all the distances. This distance, we have 10 minus x, no problem. Okay, this distance, we don't know what it is, but we can look at the sides of the triangle. That's going to be the square root of 5 squared plus x squared. Okay, or root 25 plus x squared. So that's his distance. So let's write his total time. So his total time problem. So he's going to do land distance, which would be 10 minus x divided by river distance, right? 10 minus x that he goes. And then he jumps off out of his canoe and onto the land at this point right here. So he's going to go and divide that by his speed that he's going on the river, which we said was 8. And then he's going to take time to walk across the rocky land. So that distance is square root of 25 x squared, or plus x squared, pardon me. Okay, divided by his speed on the very rocky land, it's just 3. So there's our equation for time. Okay, I'm going to rewrite it so that we have it in fraction form and so that we can do our derivative to minimize it. So I'm going to write this as time equals 1/8 10 minus x plus 1/3 25 plus x squared to the 1/2 power. Okay. So now to minimize time, we're going to have to take the derivative of this particular equation. So t prime, which is going to be a 0. All right, so 1/8, or I guess we should make it easier here. Let's not have to do the chain rule here. Let's make it a little bit easier by expanding this out so that we can then just eliminate this and have a negative x there. So we should probably go one more step and say that this is 10/8, which would be 5/4, which would be 1.25, I believe, minus x/8 plus this stuff. Okay, now it'll be a little easier to do our derivative if we expand that first part out, because then we can just eliminate this and take the derivative of 1/8 x, which we know what that's going to be. Okay, so t prime, that's 0. Okay, then its derivative of negative x is negative 1/8. Okay, that's what it is. Negative 1/8 plus 1/3 times 1/2, all this stuff, to the power of negative 1/2 times the chain rule, the derivative inside there, which is 2x. Okay, so let's simplify a little bit. Okay, this is 0, and this is an equal here. So 0 equals negative 1/8 plus, okay, 2 times 1/2 is 1. So it's going to be x, or x over 3, right? And then this stuff. Sorry, I guess it's x. Yeah, no, x over 3, because it'd just be 2 would cancel out, and you get x over 3. Pardon me there. Plus, not an x, plus 25 plus x squared to the power of negative 1/2. So let's move this over to the other side. 1/8 equals, and let's do this by putting this on the bottom. We got x over, this is going to be 3 square root of 25 plus x squared. Okay, so now we can solve by cross multiplication here. Okay, solving by cross multiplication. So we got 8x equals 3 25 plus x squared rooted. All right, so now that we've got that, we have to get rid of this 3 so that we can square both sides. So we've got to go 8 divided by 3. 8 divided by 3, it's 2 2/3. X, so 2 2/3 x, we'll just write it as 2.67 x equals this stuff. Okay, eliminate. Now, if you want to not have to round off, you can leave the 2 2/3 on your calculator like this, and then when you square it on both sides, you're going to get whatever you get. So I'm going to square that, and I get 7 1/9 x squared, or 64/9 x squared, or if you like decimals, 7.11 x squared equals 25 plus x squared. Okay, subtract the x squared from both sides. we get 6.11. I'll do 2 decimals there for the heck of it. X squared equals 25. Divide 6.11 on both sides into 25. And we get 4.09 or 4.1. One equals x squared, okay, because I divided it on both sides. And then we have to square root it. So I'm just leaving everything on my calculator when I do this. And I can round it off at the end. So square root of that is 2.02. So x equals 2.02, or approximately 2 kilometers. So if we go back to our diagram now, this is 2 kilometers, and this is 8 kilometers. So the question asked us, how far up the river should he go to reach, should he go in order to reach cabin minimum time? So we wanted this 8 kilometers. So he should go up 8 kilometers from where he is. He goes 8 kilometers until jumping to land. Okay, and there is our 2 examples that we're going to do. We did one minimizing cost and one minimizing time. Okay, so the time one uses distance over speed to be minimized, and the cost one used just the distance times the money per foot or per meter or whatever. Okay, so let's take a look at your practice. I'll just pop it up here if I can find for tomorrow. Okay, I'm not going to go, that's about 30 minutes already today. So the distance problems I have for you to practice, there are 6 of them. You don't have to do all 6, but there are 6 of them. You can work on, do a few of them, okay? So let's save that for tomorrow. But that'll be a work period on that day, which is whatever day it is here, whatever you're on here. That'll be day 5 of your work period. Okay, so I will stop recording and we'll see you guys after your work period. And like I say, always say, if you have a question, don't be afraid to get a hold of me.